In the spring of 1951, Captain Nikolai Sutyagin climbed into the cockpit of his MiG-15 at Antung Airfield, just across the Chinese border from Korea. He was 28 years old, a veteran of the brief Soviet war against Japan, and one of the most skilled pilots in the 64th Fighter Aviation Corps. The silver jet beneath him represented the pinnacle of Soviet aviation technology, a swept-wing predator that had shocked Western intelligence when it first screamed across Korean skies 6 months earlier. Sutyagin understood the mathematics of aerial combat as well as any man alive. His MiG-15 could climb faster than anything the Americans could put in the air. Its service ceiling reached above 50,000 feet, a realm where the American F-86 Sabres gasped and stalled. The aircraft carried a 37mm cannon and two 23mm cannons, weapons designed to shred the aluminum skin of B-29 bombers with a single, well-placed burst, against the Sabre 6 50 caliber machine guns. The MiG's armament was devastating. The tactical doctrine was simple and had proven effective for months. Dive on the Americans from above. Strike with overwhelming firepower. Then pull back on the stick and climb into the sanctuary of thin air where the heavier Sabres could not follow. It was boom and zoom fighting. And it worked because physics was on the Soviet side. On this particular afternoon, the weather was clear and visibility stretched to the horizon. Sutyagin spotted a formation of American Sabres 5,000 feet below, silver specks against the brown Korean mountains. He signaled the attack. 4 MiGs rolled over and plunged toward the enemy. Speed built rapidly as they dove 600 miles per hour. Then 650. The airframes shuddered as they approached the sound barrier. The Sabres scattered like startled birds. Sutyagin picked his target, lined up the optical gunsight, and fired. The heavy cannons thundered. Tracers arced through the sky. He missed. The deflection angle was too steep. The closing speed too high, but it did not matter. He had energy to spare. He pulled back hard on the stick, G-forces crushing him into his ejection seat. And the MiG responded beautifully. Its Klimov engine roared as it converted speed back into altitude. He rocketed upward, expecting to see the American Sabre falling away below, unable to follow. But when he looked back, the Sabre was not falling away. It was following. This made no sense. The Sabre was heavier. It had less thrust-to-weight ratio. It should have been bleeding energy, stalling out, tumbling back toward Earth. Yet the American pilot was hanging on, matching Sutyagin's climb with impossible tenacity. Then came the real shock. Sutyagin was now thousands of feet away, twisting through a high G climb, presenting a small and difficult target. At this range and angle, hitting a maneuvering jet with machine guns should have been statistically impossible. The human eye cannot accurately judge the lead distance required. The vibration of the aircraft, the wind drift, the bullet drop, the variables are too complex for any human brain to calculate in the fraction of a second available. Tracers flashed past his canopy. They were not wild spray-and-pray shots. They were terrifyingly precise. A stream of 50 caliber rounds slammed into the wing of his wingman's aircraft. Smoke erupted. The hit was surgical, achieved from a distance, and angle that defied everything Sutyagin knew about aerial gunnery. He watched in horror as his wingman spiraled toward the mountains below. The pilot ejected, his parachute blossoming white against the gray landscape. Sutyagin was not angry. He was bewildered. He knew the capabilities of the Browning machine guns the Americans used. He knew their effective range. That shot should not have happened. He aborted the mission and dove back toward Chinese airspace, his heart pounding, not from the exertion of combat, but from an uncanny feeling that the rules of the game had changed without anyone telling him. Back on the ground at Antung, chaos reigned. Other pilots were landing with pale faces and shaking hands. It was not just Sutyagin. Across the sector, Soviet pilots reported the same inexplicable phenomenon. They engaged the Americans, used their superior vertical performance to escape, and got hit anyway. Ground crews swarmed the damaged MiGs that limped home and found bullet holes grouped tightly together, the hallmark of a sniper. Not a fighter pilot spraying lead in a desperate turning fight. To achieve such grouping on a target moving at 600 miles per hour while pulling 5 Gs required a level of marksmanship that should not exist. The debriefing officers demanded answers. Did you slow down? Did you fly straight and level? No. The pilots insisted. We were maneuvering. We were climbing. We were outside their effective range. The political officers refused to accept that American equipment was performing impossible feats. But the veterans knew what they saw. They saw tracers curving into them from distances where the American plane was just a speck against the sky. It was as if the American bullets were guided by an invisible hand. The mystery consumed the Soviet high command. Stalin was still alive, his paranoia at its peak, and the stakes could not have been higher. The Korean War was a proxy conflict, a testing ground for the next World War. If American fighters could dominate the skies despite the MiG's aerodynamic superiority, it meant American bombers could penetrate Soviet airspace. It meant the vast air defense network the Soviet Union was building might be fundamentally flawed. Reports trickled up the chain of command to Moscow. The language was guarded, fearful. No one wanted to bring bad news to Stalin. The documents described aggressive American tactics and unusually high accuracy. But between the lines, the panic was palpable. Week by week, F-86 pilots were clawing back the advantage, racking up kills that defied every performance chart. A theory took root in the mess halls of Soviet air bases. The pilots whispered it to each other over vodka and cigarettes. They believed the Americans had developed a new weapon, perhaps a proximity fuse for their machine gun bullets, or ammunition that traveled so fast it required almost no lead calculation. Or perhaps something even more chilling, a way to control their aircraft that the Soviets simply could not understand. They began calling it the zone. It was an invisible sphere around every American Sabre. Enter it, and you died. It did not matter if you were faster or could climb higher. Inside the zone, the Americans did not miss. General Georgy Lobov, commander of the 64th Fighter Aviation Corps, and himself a World War II ace with 19 victories, was under immense pressure. Moscow demanded results. Instead, Lobov wrote letters of condolence and watched his best pilots vanish into the Korean mountains. He ordered new tactics. Get closer. He demanded. Do not fire until you can see the rivets on the enemy's fuselage. He believed the problem was Soviet marksmanship, that his pilots were firing from too far away while Americans showed better discipline. He was wrong. The confusion reached a breaking point when a highly experienced flight leader, a man with kills against the German Luftwaffe, engaged a lone Sabre in a vertical rolling scissors. This was a complex, nauseating maneuver where two aircraft spiral around each other, each trying to force the other to overshoot. The Soviet pilot executed perfectly and forced the Sabre out in front. But as he pulled the trigger, his shells went wide. The optical sight in his MiG was bouncing and vibrating. He had to guess the lead angle. He guessed wrong. The Sabre reversed. It pulled its nose around with what should have been sluggish heaviness. Yet it pointed directly at the MiG. The Soviet pilot broke hard, pulling 5 Gs. Knowing he was safe at this deflection angle, the tracers arrived anyway. They stitched a line across his fuselage, severing hydraulic lines. His controls went dead. As he ejected into the freezing slipstream at 40,000 feet, he watched the Sabre fly away. It had not sprayed bullets wildly. It had fired a short, 2-second burst, and every round had found its mark. This was not luck. This was a system. The Kremlin gave the order. Find out how they are doing it. Find out why they do not miss. Special recovery teams were formed, not ordinary soldiers, but engineers and intelligence officers from the GRU, accompanied by Chinese security forces. Their orders carried the weight of a death sentence for failure. Bring us a Sabre. Every time an F-86 went down, these teams scrambled. They raced against American combat search and rescue helicopters, often under artillery fire, trying to reach smoking crash sites before the wreckage could be destroyed. The Americans clearly had something to hide. When a Sabre crashed behind enemy lines, U.S. Navy Corsairs and Sky Raiders were dispatched immediately to strafe and napalm the wreckage. They burned their own technology to ash rather than let it fall into Soviet hands. This scorched earth policy only deepened Soviet paranoia. What were they protecting? On October 6th, Yichen Jobai Wushiyi, a breakthrough came. Second Lieutenant Bill Garrett's F-86A took hits from a MiG piloted by Captain Konstantin Shiberstov. The rounds damaged Garrett's engine and knocked out his ejection seat. As Garrett struggled westward toward the Yellow Sea, hoping to ditch and be rescued, another MiG pilot spotted his wounded aircraft. Rather than finish him off, this pilot realized the opportunity. He herded the crippled Sabre toward the coast, where it crash-landed in tidal mudflats near the shore. The rising tide hid the wreckage from American spotter planes. Under cover of darkness, 500 Chinese laborers and Soviet advisors dragged the broken aircraft from the muck. They detached the wings, loaded everything onto trucks, and drove north. The convoy traveled by night and hid in tunnels during the day. American aircraft attacked the column, but the prize survived. Serial number 49 to 1319 arrived at the Air Force Research Flight Test Institute in Zhukovsky, 22 miles southeast of Moscow. Later that month, the dissection began immediately. Soviet engineers swarmed the aircraft like surgeons around an operating table. They stripped the skin panels and removed the engine. But the ballistics experts went straight for the nose. They wanted to see the guns. They wanted to find the magic weapon that was swatting MiGs out of the sky. What they found was disappointing. They pulled out 6 Browning M3 machine guns and disassembled them on sterile laboratory tables. They measured the barrel rifling, tested the spring tension, and analyzed the metallurgy of every component. The report that landed on Stalin's desk was baffling. These were not super weapons. They were essentially the same. 50 caliber machine guns Americans had used in World War II, modified to fire 1,200 rounds per minute instead of 800. They were crude compared to the MiG's cannons, relying on kinetic energy rather than explosive shells. The engineers were confused. This is what is killing us? They analyzed the ammunition standard ball, tracer, and armor-piercing incendiary rounds. No proximity fuses, no guidance chips, no secret propellants. If the gun was primitive and the bullet was dumb, then the magic had to be in the aiming. Attention shifted to the cockpit. Sitting atop the dashboard, mounted behind armored glass, was a black box labeled AN APG-30. To the untrained eye, it looked like a standard reflector gunsight, a piece of glass where a glowing reticle was projected, similar to what the Germans had used in their Bf-109 seconds, similar to what the Soviets themselves used in the MiG-15. But when they opened the casing, they found a density of wiring and vacuum tubes that looked less like a gunsight and more like a miniature computer. The unit was packed with delicate gyroscopes, magnetic amplifiers, and a complex web of circuitry. The problem was that the unit was smashed. The internal gimbals were crushed. The vacuum tubes were shattered glass. The Soviets could see the components, but they could not make the device work. They could not power it up to witness the ghost their pilots had been reporting. They began reverse engineering the schematic and noticed the site was connected to a small radar antenna in the nose of the aircraft. Radar ranging. The chief engineer muttered, "They are using radar to determine distance." This was a significant finding, but it led them to a dangerous conclusion. They assumed the radar simply told the pilot how far away the target was, adjusting the reticle size accordingly. They had similar concepts on their own drawing boards. But a range-finding radar did not explain the lead, the ability to predict where the MiG would be 2 seconds in the future. The investigation turned to captured American pilots. In the grim interrogation rooms of North Korean prison camps, prisoners were brought before Soviet officers. These men were exhausted, wounded, and terrified. The interrogators did not ask about troop movements initially. They asked about the box. "How do you aim?" the interrogator demanded. "Do you calculate deflection manually?" The American pilots, briefed to say nothing about classified systems, played dumb. Or perhaps they were telling the truth when they admitted they did not really understand how it worked. "I just put the pipper on the target and pull the trigger." One pilot said. This infuriated the Soviets. At 600 miles per hour, if you put the reticle directly on the target, the bullets will pass behind. You must lead. How do you calculate the lead? I do not. The American insisted. The box does it. The box does it. This phrase filtered back to the Kremlin and took on almost mystical significance. The pilots stopped calling it a gunsight. They called it the electronic brain. Rumors spread through Soviet air bases. Some believed the Americans had connected the radar directly to the flight controls. That once an American pilot locked onto a MiG, the Sabre flew itself, becoming a robot assassin. They believed the American pilot was just a passenger, there to press the button when the light turned green. This theory was terrifying because it removed the human element. You can outfly a man, you can trick a man, you can frighten a man, but you cannot frighten a gyroscope. You cannot trick a calculator. While Soviet generals screamed at their pilots and intelligence agents sifted through charred wreckage in Korea, the answer to the mystery sat calmly on a laboratory bench in Cambridge, Massachusetts. It was not a weapon forged in the nuclear fires of Los Alamos. It was not alien technology. It was a mathematics problem, solved by a genius who understood that the human brain had reached its evolutionary limit. The source of the ghost in MiG Alley was the instrumentation laboratory at MIT, led by Dr. Charles Stark Draper. Draper was not a fighter pilot. He was an engineer who viewed war as a series of equations. Born in Missouri, in Milano Vicentuno, he had earned degrees from Stanford, Harvard, and finally MIT, where he received his doctorate in physics in 1938. By World War II, Draper had established himself as the nation's foremost expert on gyroscopic instruments. The Navy called him to develop stabilized gun sights for anti-aircraft guns on warships. His Mark 14 gun sight proved devastating against Japanese aircraft. Close to 80% of enemy planes shot down by U.S. Navy ships in the final months of the Pacific War fell to guns equipped with Draper's technology. But Draper understood something fundamental about the jet age before anyone else. Speed kills accuracy. In World War II, aircraft flew at 300 miles per hour. At that speed, a pilot with good instincts could estimate the lead angle required. He could look at an enemy fighter turning in front of him, guess how far ahead to shoot, and squeeze the trigger. It was an art form, relying on what pilots called Kentucky windage and gut feeling. Draper studied the numbers for jet combat. 600 miles per hour. Closing speeds of 1,000 miles per hour. At those velocities, the geometry of an intercept changes faster than the human eye can transmit data to the brain, and faster than the brain can send commands to the hand. By the time a pilot sees the enemy, decides to shoot, and moves his finger, the enemy has already moved. Draper realized that asking a pilot to calculate ballistics at Mach 0.9 was not just difficult, it was mathematically impossible. The pilot did not need a better gun. He needed a partner. He needed a machine that could predict the future. The project was codenamed the A1 series, eventually evolving into the A4 gun sight paired with the AN APG-30 radar in the F-86. The heart of the device was not a microchip, those did not exist yet. It was a gyroscope. But not just any gyroscope. Draper had perfected a technology called the floated integrating gyro, a small, precision-machined spinning top suspended inside a cylinder filled with thick, viscous fluid. This fluid dampened the vibrations and shocks of a fighter jet, allowing the gyroscope to sense the aircraft's movements with absolute precision. In a traditional gun sight, the crosshair was fixed to the glass. Where the nose pointed, the crosshair pointed. Simple. But in Draper's sight, the crosshair was not fixed. It floated. When an American pilot banked his Sabre to follow a turning MiG, the gyroscopes inside the sight felt the G-forces and rate of turn. They physically moved the projection of the reticle on the glass. The crosshair drifted away from the enemy aircraft. This seems counterintuitive. Why would the sight move away from the target? It was a psychological trick of brilliant elegance. To get the reticle back onto the target, the pilot instinctively pulled the stick harder, tightening his turn. By chasing the dot, the pilot unknowingly forced his aircraft into the perfect lead angle. The sight was doing the calculus, measuring the turn rate, the atmospheric density, the ballistic trajectory of the bullets. It was saying, if you want to hit that MiG, you need to be aiming at this empty patch of sky where the enemy will be when your bullets arrive. The pilot did not have to guess. He just had to obey the dot. The AN APG-30 radar completed the system. This small ranging radar sat in the nose of the Sabre. When the pilot closed in on a MiG, the radar automatically locked onto the target and fed the precise distance directly into the gyroscopic computer. The gyros measured the turn. The radar measured the distance. The computer calculated the spot. All the pilot had to do was fly so that the glowing orange diamond rested on the silver fuselage of the enemy aircraft. He did not have to lead. He did not have to calculate. He put the thing on the thing and pulled the trigger. It turned average pilots into snipers. It turned good pilots into legends. The Soviets eventually captured an intact gun sight. Another Sabre went down without burning. Its delicate internals preserved. Engineers crated it up and flew it directly to Moscow. What they found inside would not just explain the slaughter in MiG Alley, it would force them to confront a terrifying truth about the technological gap between East and West. In a sterile, high-security laboratory, Soviet engineers pried open the casing. They expected to find something alien, something beyond their understanding. What they found was far more shocking, a level of manufacturing precision that did not exist in the Soviet Union. The lead engineer placed a component under a microscope and called his colleagues over. They took turns looking in silence. The clearance between the spinning rotor and its housing was measured in microns. The fluid suspending the gyro had a specific viscosity and chemical composition that Soviet industry had never produced. The wiring was woven with a delicacy that resembled jewelry making more than military manufacturing. The Americans had not won MiG Alley because they had better pilots or faster planes. They had won because they had better machinists. The mystery of the ghost bullets was not a tactical trick. It was a symptom of a widening industrial chasm between the superpowers. Stalin's reaction was predictable. He did not want explanations about manufacturing tolerances. Copy it. He ordered, screw for screw, wire for wire, make it identical and put it in our MiGs. This order set in motion one of the most frustrating chapters in Soviet aviation history. The Soviet industry mobilized to clone the American sight, designating the copy the ASP-4. On the outside, it was identical, same glass, same dials, same rather connection, but building the internals required dust-free clean rooms, temperature control stable to within a fraction of a degree, metallurgy free of microscopic impurities, and machinists trained to work with tolerances measured in millionths of an inch. Soviet factories were fast, powerful beasts designed to churn out thousands of tanks and rugged tractors. They were not watchmaker shops. They rushed production to meet party quotas. They substituted materials when American alloys were unavailable. They accepted tolerances that were good enough for a tractor but fatal for a computer. The result was a zombie, a clone that looked like the American masterpiece but lacked its soul. When the new sights were rushed to frontline units, the pilots were initially ecstatic. They believed they finally had the magic eye. They took to the skies, engaged American Sabres, locked the radar, and watched the reticle appear. Then it drifted. The Soviet gyros were not perfectly balanced. The fluid was not pure. Under heavy G-loads, the delicate mechanisms rubbed against the casing. The floating effect was lost. The reticle did not move smoothly, it jumped, to wandered, and lied. Imagine the horror of a Soviet pilot diving on a Sabre. Trusting his new electronic brain, he puts the pipper on the target. He fires. The shells miss by hundreds of yards. The sight tells him he is on target. But the cheap copy is betraying him. He tries to correct, but the sight lags and jitters. The pilots return to base furious. The box is broken. They screamed. It is trying to kill us. Maintenance crews attempted to calibrate the sights, but you cannot calibrate away a fundamental lack of precision. The reputation of the Soviet copy collapsed overnight. Pilots lost faith. They reached up and physically caged the gyroscope, locking it in place, turning the advanced computer back into a simple fixed crosshair from 1945. They went back to guessing. They went back to Kentucky windage. Meanwhile, across the Yalu, American pilots flew with the original article. Their sights hummed perfectly. They trusted the machine. By the end of the war, American pilots claim to have destroyed 792 MiGs for 78 Sabres lost in air-to-air combat. Modern historians with access to Soviet archives suggest the actual ratio was closer to 2 to 1. But the trend was undeniable. The MiG-15, aerodynamically superior, was being hunted. Senior Lieutenant Vadim Matskevich, a Soviet engineer assigned to analyze the captured Sabre, reached a conclusion that nearly cost him his career. He wrote a report stating bluntly that the F-86 Gunsight was superior to the Soviet design. In Stalinist Russia, questioning such decisions was dangerous, and Matskevich received 30 denunciations from other engineers. But he survived by solving a different problem. If the Soviets could not match the American sight, perhaps they could blind it. Matskevich designed a warning receiver that detected the signal from the Sabre's radar and alerted the pilot when he was being targeted, the same principle behind modern radar detectors. The device was simple, a basic receiver mounted on the tail. But it worked. Soviet pilots began receiving warnings when American Sabres locked onto them. It did not solve the problem, but it gave them precious seconds to evade. The system was rushed into production and became standard equipment on Soviet fighters. But it was a defensive measure, an admission of defeat in the technological contest. The Korean War ended in July 1953 with an uneasy armistice. The guns fell silent over MiG Alley. Pilots went home. But in the classified archives of Moscow and Washington, the war over data was just beginning. The real victory was not measured in destroyed aircraft. It was measured in the psychological trauma inflicted on the Soviet military-industrial complex. The mystery of the A-4 Gunsight planted a seed of doubt that grew for 40 years. It proved that superior aerodynamics, the curve of a wing, the thrust of an engine were no longer enough. The MiG-15 was a better flying machine than the F-86 Sabre. It could reach higher altitudes and accelerate faster. In a pure contest of physics, it should have won. But it lost because the Americans brought a computer to a knife fight. The failure of the Soviet ASP-4 had devastating consequences. It forced the Soviet Union into a reactive posture from which it never escaped. Instead of innovating their own solutions, they became obsessed with theft and imitation. They spent billions of rubles building networks of spies to steal Western technology, only to find themselves unable to manufacture the designs they stole. They were like a cargo cult, building wooden replicas of radios and hoping for music. They could copy the shape of a microchip but could not replicate the purity of the silicon. They could copy the gyroscope but could not produce the fluid. This imitation trap defined the rest of the Cold War. It appeared in the Tupolev Tu-144, the so-called Concordsky, a copy of the Anglo-French Concorde that was louder, more dangerous, and flew for only a few years before being grounded. It appeared in the Buran space shuttle, a near clone of the American orbiter that flew exactly once before being abandoned. Again and again. Soviet industry proved capable of copying Western designs, but incapable of matching Western precision. The incident in MiG Alley was the first clear signal of the Soviet Union's ultimate fate. Their economy was built for gross tonnage, millions of tons of steel, thousands of tanks, vast concrete dams. It was an economy of giants. But the future of warfare belonged to the midgets, the transistor, the microswitch, and the floated gyro. The Soviet system simply could not handle the delicate requirements of the information age. The F-86 Sabre and its secret sight marked the death of the Knight of the Air. Before this moment, the fighter pilot was a warrior poet, a man of instinct and reflex who looked with his eyes and killed with his hands. After this moment, the pilot began his transformation into a systems manager, The A4 Gunsight was the ancestor of the modern heads-up display, the great-grandfather of the aim-assist algorithms in the F-35 Lightning. The first step toward a world where the aircraft flies itself and the pilot merely authorizes the kill. The pilots of the Soviet 64th Fighter Aviation Corps went to their graves remembering the zone. They remembered the impossible shots, the tracers that seemed to curve like magic, and the terrifying realization that the Americans were not just fighting them, they were calculating them. Nikolai Sutyagin survived the war and went on to become a major general, credited with 22 aerial victories that made him the highest-scoring jet ace in history. But even he never forgot that spring afternoon in 1951, when the rules of aerial combat changed forever. The mystery was eventually solved. The lesson, however, proved fatal. The Soviet Union spent the next 4 decades chasing the ghost of American technology, running a race they had already lost in the skies over Korea. And in a laboratory in Cambridge, Massachusetts, Charles Stark Draper had already moved on to his next project, building guidance systems for missiles that could strike targets on the other side of the planet. And eventually, navigation computers that would land men on the moon. The ghost of MiG Alley was just the beginning.